Given this function, our question is, does the mean value theorem apply? And there are a few conditions: continuity, differentiability. Okay, well, if it does apply, we're going to find that value of c, call it x, where the derivative of the function is the same as the slope of a secant line with these particular values of x and their corresponding y values. Okay, so is the function continuous? Yes, it is. It's a polynomial function. We don't have any discontinuity, no holes, no asymptotes. The next condition, is the function differentiable? Well, sure. I don't have any discontinuity. Okay, I don't have any sharp corners or cusps. So yes, the function is differentiable. Yes, the function is continuous. Okay, so let's take it a step further. Now that we know that, let's find the derivative. The derivative of x cubed is 3x squared. The derivative of 2x is just 2. The derivative of 4 is 0. We don't write that. So I've got the derivative. The next thing we need to find is the slope. Okay, well, just like you did in algebra, it was the change in y over the change in x. So the function values go on top of the x values. And the order doesn't matter, but being consistent does. To find those function values, we're going to plug 0 into the function. When we do put a 0 in here, when we put a 0 in there, we end up getting that the y is 4. When we plug a -1 in, we plug it in here, we plug it in there, we end up getting that the y is 1. And down low, I've got a double negative that does turn out positive. So this slope is 3 over 1, which is just 3. Now, you know, we could slow that down. We could go ahead and investigate in a proper manner. What is f of 0? Plugging the 0 in. Nothing, nothing, and 4. Okay. Plug in the -1 in. The cube of -1. 2 times -1. And you add 4. That's a -1. Take away 2. Plus 4. It really is 1. Okay. So remember now that we do have our derivative. We said that our derivative is 3x squared plus 2. We've also got our slope. We said our slope is 3. We're going to set these equal and take it that one step further and find that value of c, or call it x. So let's see. That would be 3 is equal to 3x squared plus 2. I'm on the quest for x. I'll move 2 to the other side with subtraction. I'll undo times 3 with division. We'll reverse the square, and you know how. We take the square root of both sides. So when I do take the square root of both sides, we say x is going to be a positive or a negative. The square root of 1 is 1. The square root of 3, well, that's not a perfect square, so it has to stay. We got 2 values of x, but we're only looking on this interval between -1 and 0. That means that we're going to get to keep -1 divided by the square root, 3. But we've got to toss out 1 divided by the square root of 3 because that's positive and it's not on the interval. Now we can say that c would be -1 over the square root of 3. If we rationalize that denominator, that's negative square root 3 over 3. Call it c, call it x, but we did find that value of x, where the derivative of the function is the same as the slope of the secant line. The end.